Okay, thanks for joining us this evening for this Docker meetup. It's an exciting one. We have some awesome panels here. We're going to be talking Docker.
You just make way up.
Yeah. Can you guys hear me in the back?
Now we can.
Okay.
There's chairs at the front as well.
Yeah, there's chairs in the front. You can hear it easier here. So without further ado, I'm just gonna let Carl, who's the head of the panel, start.
I'm not heading anything. I'm moderating lots. I'm not leading anything.
He's here to de-head.
Yeah, no, absolutely. I'm advocating all leadership.
Okay, that's what he's gonna do. Just want to thank the sponsors, OpenDNS and Aro for sponsoring the event. There was a mix-up, so didn't get to order pizza today, but sorry about that. We'll get it next one.
We live?
Yeah, this event's going to be recorded, so the link's going to be put on YouTube, and it's going to be shared on the meetup event. Is that?
Where's the camera?
Camera's right here.
Oh, there.
Yeah. Hope we can test the volume. And if you guys are interested in free, well, if you guys sign up on that sheet over there, Oro can give you $250 credit for hosting, and then there are free Docker t-shirts there, so and stickers. So feel free to grab some. I'll let Carl start.
Perfect. So is this our this is our mic? This is do I just like toss this at the guys?
I don't know, Andrea. Yeah,
that's cool.
Toss it around.
All right, excellent, cool. So guys, hey, thank you so much. I'm super honored to be your moderator tonight. I'm hoping I'll be a pretty good moderator because I know just enough about Docker to be dangerous. So I'm going to help ask all the stupid questions, and hopefully we've assembled a fantastic panel that's going to answer all of your Docker questions. So our schedule tonight is pretty casual. We're going to budget for about an hour of intense panel grilling. And then we're going to open it up for Q&A from the audience for about a half an hour, and then we're all going to consume whatever beer is left and talk Docker for the rest of the evening. So does that sound good? Is that all right? Excellent. I see nods. Fantastic. Okay. So the first thing that I always like to do is do a little bit of calibration, right? I mean, whenever we're running systems, there's a bit of a system that we're running here. It's important to know what you're dealing with. So first of all, just audience calibration here. Who has heard of Docker or has not heard of Docker or has heard too much about Docker? Either of those, any of those. Okay, so I'm torn here because, clearly I should have had about 100% hit on that, and I've got about 50-50. So when we're asking audience questions, we're just going to have to kind of calibrate with this 50% response rate. So thank you very much. Reliability I'm getting from our audience here, 50%. Good stuff.
Packet loss.
What's that?
Packet loss.
Yeah, exactly. It's absolutely so. Okay, so you'll have to self-calibrate when you look around. I'm going to poll the audience here really quickly. How many of you are, not necessarily production or not, but using Docker in any kind of way at all today? Like getting some use out of it, value out of Docker. Wow, so more of you than have ever heard of it. Thank you very much. That's amazing. All right, so the next one, I'm expecting a bit of a drop here. How many of you have Docker in a production environment? Wow. All right, so you guys are like right at the bleeding edge. How's that working out for you? Lots of pain, lots of Band-Aids? Yeah, okay, good. All right, so then of the rest of you, how many of you think, all right, you know what? Yes, I get Docker. I absolutely need this today in my environment. This is something I need. Wow. Okay. All right. How many?
You're just here for the beer?
What's that?
You're just here for the beer?
Yeah, totally. I know it's interesting, right? Okay. How many of you are like, okay, well, it's interesting, but I'm not quite sure where it fits? Yeah. Exactly. Okay. Cool. And then this one's a fun one. Everyone's talking about it, so I guess I better find something to use it for. Yeah, totally. All right, cool. Okay, so without further ado, I'm going to let our panel introduce themselves and answer for you who they are, if you guys haven't met yet, and what their Docker experience is to date. So, Mike, you want to kick us off?
Hey, I'm Michael. I do computer game stuff. I do one where we run online services for Call of Duty and some other games you might have heard of. I'm pretty jet lagged, so apologies. I've been using Docker for quite a while. Definitely in the point of something for other days. I think I'm at the point now where I realize that it's definitely not going to solve all the problems, but it's useful tool in the toolbox, and it's something that I tend to have as part of like a build job or something else like that. And I'm doing a lot of work later this year on how to run containers of some kind, not necessarily Docker in production.
I'm Mark Arsemans. I'm an engineer at Hootsuite. We're using it in our build system at the moment. We have Docker running and being orchestrated with Mesos. And we are looking to put our first service in production with Docker probably in the next few months. That's the next step in our roadmap. So yeah, let's build more around.
Hi, I'm Phil Whelan. I work for ActiveState. I'm a software architect. And we create a product that has Docker running under the hood. And we've had Docker under the hood pretty much 9 months after Docker was released. And before that, we were using LXC containers, so it was a pretty simple switch.
Hi, I'm Tavis. I work for Carl. I've been using LXC in production since about 2011 and playing with Docker since reasonably early days. I feel completely out of date now looking at the changelog in the last couple months. So I'm here to give you wrong answers to everything that's changed since. Using Docker for dev and build environment for just over a year now, and for some very minor client stuff, mail daemons and other small things in sort of production. Things that I would not be embarrassed if they went down for $100. So nothing serious.
Cool. All right, so just like our audience calibration, I need to make sure that our panel here is not faking their experience with Docker. So, quick little trivia question. When was Docker originally released?
March 2015.
Not bad, exactly. So March 2013. But think about that. So Docker's not even 2 years old yet, right? I mean, and we're hearing about it every day. So that's pretty incredible. Docker 1.5 was released yesterday. Any features you can name that are important?
IP6. IP6.
Yeah.
You don't have to have your Docker file called Docker file.
Totally. Yeah, that's a big one. Yeah. There's some other really good stuff though.
Stats?
Yes. Yeah. Stats is in there.
I was looking at it before it came.
Yeah, no, that's not cheating at all. That's awesome. Any other? I kind of like the
well, jumping back to something else I was reading in the changelog.
Yeah.
Filtering on events, which I think was actually Docker 1.4, is a nice addition as well.
Right. Yeah. Read-only containers. I thought that was pretty cool. Yeah, depending on what you're doing with it. Okay, and
just to say that you could actually have done that pre-lib container back in the LXC days. You could have made it read-only back then through the LXC config.
totally. Yeah, but mere mortals kind of like.
Yeah.
Okay. Legally, so who owns Docker? I actually had to look this up.
Docker.
Yeah, but like that kind of because I was reading about the history and everything. Yeah, exactly. But it is open source, right? Yeah, totally. Okay, cool. Totally. You're never going to get this one. Last one, I promise. Then we'll get into the really meaty stuff. Who created the Docker logo? Anyway, I know. It was a 99 Designs guy, which is kind of cool, right? Because like 99 Designs, so you actually get like good logos out of that. And so there you go. If you want a ripped off fail whale, go to 99 Designs. This is recorded, right? I'm going to ask for an answer from each of you on this one, so I'll pass the mic down. Because this is a fundamental, important one. What I want to know is, and I'm sure everybody here, it sounded like wants to know, what fundamental problem does Docker solve, and why on earth is it so popular? What's all the hype about? Like, what is Docker actually doing for us that we couldn't really do easily before? Where does it fit in? What problems are you looking for Docker to solve for you?
Personally, it's a really quick, convenient way to have a big fat binary wrapper with all the dependencies around whatever data you want to run, so you can take it, run the exact same image in whatever environment. So that's why I like it.
Yeah, for me, that's actually the same answer. It's the strongest thing is as a package manager, almost, for a way of encapsulating dependencies. So, if you're a Java shop, developers would traditionally make a jar, but devs care what is inside of that jar. Ops generally put in a machine and put somewhere. Now, there's all these other kind of dependencies that get kind of thrown around with an application, or you might be a polyglot shop, such as we are. That gets really complex. It gets really hard. So it's a unified interface between ops and devs. It's not like create a container, screw your ops, deal with it, but still that same kind of thing. Like we need to know, we have to have a consistent way of working with each other. I think it's a great interface. With Frank for the two responsibilities.
Yeah, the packaging thing is really cool because I can build something like WordPress and I can put it in a Docker image and I can upload it to a repository and anyone can just download that and run that. And you can install Docker in a single line and then you can do Docker pull and Docker run, and you're running this application that you have no idea what's in that Docker image, and the developer who created that doesn't actually know what Linux you're running it on. Those are the only dependencies you need. So that's cool. Process isolation is pretty cool as well. Being able to run lots of containers on one system, and then the whole way it uses like layering and a copy on write, so you have really fast bringing of the containers without changing the disk. You have multiple things running.
It makes me feel less guilty shooting bash scripts. I can put things in a nice little facade where it's a unified interface to everyone else and not feel guilty about the crap inside. I suspect if you looked inside a lot of Docker shared images that are out there, Docker Hub and elsewhere, you'd find a lot of crap inside. But the main thing for me is on nothing to do with production, but just in a dev environment. I love being able to do everything from scratch quickly. So repeatable builds, but not walk off and get your coffee repeatable builds. Instant gratification repeatable builds.
Cool. So, you know what, actually, just hang on to that. I think I'm loud enough here. So, interestingly then, a lot of that was about kind of isolation and packaging and everything. Does Docker remove the need for VMs? I mean, it sounds actually similar. There's a lot of overlap between what Docker gives us and what VMs give us. So I guess you could think of it, does Docker remove the need for VMs? How is it complementary? How do we kind of compare between what VM machinery gives us and what Docker gives us?
That very much depends on the application you're trying to run in the container or the VM. So if it's a pretty simple web app and you expose a single port, Docker is super, and for all intents and purposes, it's identical to the VM, but significantly more lightweight. If you're doing anything interesting with networking or lower level, or need access to devices, or to interoperate with other networks and other devices, it can get more complex to do in Docker. There's also things like if you're need to run Upstart or Systemd or something else to supervise your application, say you're doing service discovery, you have to do a lot of workarounds to run an init system within Docker or outside of Docker because of the sort of clash between Systemd and Docker and process flow. So it depends. For simple applications, it's fine. For other applications, you're going to very quickly run into rough edges where it's not quite production-like or not quite like a real system.
I just wanted to talk about init systems. So with the exception of Upstart and Systemd, you can actually run init whole install init systems inside. So should you want to take something that wouldn't actually be a VM and stick inside of Docker, provided you're not stuck on a distro or bound to that distro's use of Upstart or Systemd, don't mind writing a little Python configuration for supervisor D or using another init system. You can do that inside. But you're not going to find too many examples of people saying, yes, that's a good idea.
Yeah, I think with VMs, you can run different versions of the kernel, whereas with Docker, they've all got to share the same version of the kernel, so you could do testing where you've got different kernels and plugins, or you want to run something on Windows, you can't fit those all in different Docker containers when Windows does support Docker containers.
Yeah, and security as well. It's there are holes in Linux namespace. It's not perfect yet. I'm confident it's going to get a lot better. There's so much kind of focus on containers and namespacing and the rest of it. There's still holes. There's always ways to break out the container. So that, if you're really concerned about security, concern. But as a single company running, microservices, less concerned about those security implications.
Yeah. Yeah. So I noticed Mike is studiously in his jet lag state going over the pre-prepared questions here, but I'm going to throw a curveball and say that, okay, so that actually opens up a bigger question. If we're concerned about granularity of services inside a Docker image, if we're running Upstart or something like that, it's nice to have flexibility, but at the same time, now how do we think about decomposing a system into Docker images? Because you can have 100 Docker images, or 200, I was talking to somebody here, you can have very, very many, and that can be a good or bad thing. But how do you start to think about an appropriate level of decomposition in a Dockerized system? Because you could run your whole stack in a Docker image, you could break it down into all of the individual services. As somebody who's looking at a running system, what do you think about in terms of how to partition that system into Docker images?
You can answer what line is it?
That's your one lifeline.
So, the original intent of Docker was to run like processes, like one-to-one, one process, one container.
Right.
But as soon as Docker was born, people were like, oh, we can run multiple processes in here, and have an init as the first process, or run supervisor D as the first process, and then spawn lots of processes. And then people started thinking, oh, we could try and run these as VMs. And so a lot of work went into that, and a lot of people have been trying to do that, and then complaining that, oh, Docker doesn't run like a VM. So for me, I still think the one process, one container is probably the best model. So any architecture you've got a whole bunch of processes running. So take each one of those processes and put it in a container, package up all the dependencies, everything that single process needs to run, and then just run it as a Docker container. That's an easy way to slice it up.
Let me just say for 1 second. So most people talk about running a daemon inside a single process or a collection of processes that sort of compositely make a daemon. But you can also run individual short-lived processes inside. Say that you just have a build system that you want to isolate. Nothing to do with production, but you want to isolate the production of your software unit that you're then going to ship somehow. I think it's useful from that perspective as well. And then VM versus Docker container. The benefit of Docker container in that context is it's faster. Faster if you're building up things from scratch or part way from scratch over and over again. In terms of how to decompose an application you might already have versus a greenfield thing that you're going to design the correct way from scratch. If you need to have some other sort of non-network coordination between Docker containers, rather than just talking TCP or UDP between the containers, you can also mount shared file systems or shared devices into a collection of containers. So you can cheat. It's not quite VM versus container. You could go part way and then let the Komodo a bit and stick something in.
Yeah, the one process per container, I think philosophically is I agree with that, but any philosophy you take to an extreme is fascism. And you have to sort of be able to break the rules. Even the Docker registry that is from Docker, is Unicorn, Python Unicorn. So it's a multi-process thing. It's like, it spawns off subthreads and dispatches through pipes and whatnot. So it's a logical unit of responsibility, right? And I think that's the core important thing. In most cases, an application encapsulates that core logical unit. So yes, but you got to break it sometimes. Like sometimes you just got to do something wonky. Like if you have I put Jenkins in a container, but I put that with supervisor D because I didn't, if Jenkins went down, I didn't want to have to go and respin the container because it's so heavyweight, it's got to do all this initialization process, or maybe you've got a service that has to do all this like cache warm up and all this other kind of stuff. So yes, but you can break it, I think, when it makes sense, right?
Yeah, totally.
Yeah, I was trying to get at the phrase that I think it makes sense to have like a service instance, whether that's a single process or, as Mark said, a multi-process. But you have an instance of a service, you spin it up, and it's bundled up nicely as a Docker container, and you can run the service in stage, in test on your laptop, and many instances using Vsauce or Kubernetes or something in production. But it's that instance, whether it's a process or a cooperating collection of processes.
Question for
Go
you.
ahead. Yeah, go ahead.
So those of you who stuck your hand up for using it in some capacity, how many of you are doing the one true way, 12-factor single process container? Or how many are cheating and putting lots of things in there?
Which?
So doing the one true way, one process, and many things inside.
You don't have to be shy.
I mean, it depends how you're using Docker and what you want to get out of it. There's an intrinsic tight coupling with Docker and the process, so that if the process dies, Docker knows about it. You'll get an event through Docker events. If you subscribe to those, you'll see that the thing died. Docker can actually restart the process. Yeah, so that's pretty new. Docker can actually restart the process for you, and you be your process manager. But it has a tight relationship with that process. If you make that process supervisor D, then Docker has no idea what's going on in the container. And if the process is failing in some way that your process manager inside doesn't handle, then there's nothing you can really do. You have to go and manually kill that Docker container. So then you're building infrastructure around Docker, which Docker is building to handle processes.
Right. So actually, are we then just missing a little bit of essential machinery in the Docker universe? Because Docker has this wonderful land where I can go and download like a full working stack. But right, I mean, I can get WordPress as a Docker image. But what you're saying is what I really want is a suite of Docker images that gives me my database, my web server, maybe some other tier in there, and I can specify somehow that those work together. But that's kind of missing I got to handle that today, don't I?
Well, if you're using like Kubernetes, so Google has been using containers for many, many, many years, and they have this concept of a pod, which is a collection of processes that all go together.
Yeah.
And so Kubernetes is becoming a very popular way to distribute Docker, and so you define a pod, which is a collection of containers. So you don't have that in the Docker registry, where you say, I want to download this Docker pod, which is a collection of things. You have to download each one yourself and construct a pod, but it's possible that would become in the future.
Yeah.
So counterpoint to the assumption or the implication that that's what you're doing is not already there. So how many of you are running a collection of VMs that have to work together somehow? How do you orchestrate that? Ansible, Salt, Chef, Puppet, other tools on top of it. The tooling exists, and you can use it to do this sort of stuff as well. Every single one of the ones I just said has support for Docker and doing that sort of orchestration. So even though it may not be the blessed Docker way of doing that orchestration, there's plenty of other tooling that we've been using for quite a while that does that sort of stuff.
Yeah, you can also put Chef and Puppet inside the Docker containers.
Yeah.
You can, but should you?
No.
All right. So we briefly mentioned 12-factor apps, and what I wanted to know from the panel is, where does Docker sit in the universe of 12-factor? Is it one of the bullet points? Does it span a whole bunch of them? Is it the way to do 12-factor?
It's a gateway drug.
Yeah. Can I expand on that a bit?
Well, a lot of people are interested in maybe using things like Heroku or some kind of path service or Docker. But the common denominator there is the 12-factor app. If you start with Docker, then you're kind of set up to run anywhere that 12-factor app works. You're running the likes of standard air, standard error. You're getting all your configuration from environment variables, which are pumped into your app. There's a whole bunch of things. 12. But yeah, it defines like a 12-factor app. So if you construct it in a new way, I mean, obviously you can put legacy apps inside a Docker container and not follow the 12-factor app thing, but it's definitely a good start. So you can transition that, even if you don't want to use Docker and you want to use something else. It's a good start.
So just actually a little more on that is, so Docker is a way where you can take a legacy stack that's not, say, 12-factor and get a little bit closer.
Yeah, I mean, you could do bit by bit. So you could be running your logs to like a shared volume, and then you could change it to write your logs to standard errors there, and then pipe those somewhere. You could have configuration files, but then decide later you're going to pump in that configuration by environment variables because you've got this external system to manage those configuration. And you can do piece by piece.
Or you could cheat and take your legacy app that is definitely not 12-factor, stick it inside, and make the Chef Solo or Salt Local or something like that do the bootstrap from the environment variables and other stuff that's being passed in, and make it look to the outside like really is 12-factor, and walk away and say, okay, good job.
Well, I've kind of done that recently. Recently, passing environment variables into a legacy app, but then inside the initial kickoff entry point script would take those environment variables and run it through Jinja 2 script and output the files, boot up the process, and then go.
Yeah.
So it 12-factorized it by kind of wrapping it. Basically, what you're saying is like, you don't feel so guilty about, distributing your ugly bash scripts through Docker.
Yeah, it sounds like a confession. Do you feel better?
It's like Docker Anonymous.
A good way, I think, of the 12-factor apps is it's kind of a forcing function. So 12-factor is very much a manifesto. It's a sort of statement of idealism. It's kind of like a policy, and it's kind of hard to force. Sometimes without tests or something to force you to fit that policy, it can be very hard to actually build something that adheres to that policy in a good way. And Docker is a way you can run on your laptop and see a 12-factor app in action. So it's like more of an API than a policy, but they're very related.
Cool. Okay, so any new technology comes along and there's immediately a gazillion questions, and so this is always a fun one because everybody has pretty different notions of how to define this. So I'm just going to drop this question and let the panel run with it. Is Docker secure?
I don't think computers are secure.
I really actually don't have much to kind of comment on that. It's not my specialty, and it hasn't really been a concern for my domain. The machine and the application itself needs to be secure. I'm never going to be running containers, co-locating it on the same box as some other people. I would never do that. So it's essentially just a way of running it on a machine in the same sort of way that I would run, a Java app in the same machine. So I don't. The whole, idea of it being run as root is a bit of a concern, but I can't really speak too much about the security aspects. So I'll pass along.
So there's no current security vulnerabilities, but the user namespacing is a little bit worrisome. The fact that it shares the same user ID as the host machine root, which hopefully will be addressed at some point. And the problem with that is if a vulnerability is announced, then you could potentially break out of the container as the root user because you're the root user inside it. Like in our product, we have Docker containers, and we give this product to people who are running production in multi-tenant systems. So one constraint we've had so far is that we use Docker under the hood as kind of implementation detail, but we don't allow people to get root access. So basically, we provide the base container, and then we use like Heroku build packs to build up the stack. If someone gives you their own, set the sudo ID to drop down to root in any scripts, and then pick up roots. So yeah, that's what it's.
What Michael said. One addition though, so the WordPress that he talked about putting inside of a Docker container, I'd be more worried about out-of-date Docker images being shipped around and shared freely, especially with something like WordPress. How many of those plugins have been updated? So if you've got a system that's built on top of layers and layers of images, or a collection of different containers working together, do you have some sort of orchestration around that to make sure you've actually got your patches applied? I'd worry more about that than I worry about breakouts.
Yeah, I mean, you don't really want long-running containers, because if a vulnerability in your base operating system comes out, you've got to either apps get updated, go into the container and app get updated or something, or create a new one and deploy that. So you want to be able to have the containers be ephemeral, so that you can quickly roll out a new version with the new base layer. So it actually means building that whole stack up.
I was just going to say, less liquidly, it can help as part of sort of a layered security approach. So, you should have security composed with multiple layers, and Docker is one layer that makes it hard for someone to break out of and jump sideways or up and down within your network, but it should be far from the only layer you'd come up. You need to have like IDS and logging, have clear visibility on what your applications are doing on the network. There's lots more to security than just going, oh, I've put this in a Docker container, no one will ever break out.
Cool. Okay, so for those of us who are trying to get Docker running on our desktops, and we're not, maybe some of us aren't running Linux on our desktop, I confess, I'm sorry, I'm not. Docker on Windows or Mac, are we going to see it? Is that going to happen? And Ubuntu Docker's fine, it's okay, but it'd be nicer to have something a little bit more native. What do you guys think?
I just use Ubuntu Docker, what's wrong with that?
It's another piece of machinery to worry about.
Yeah, I'm gonna pass on that. I frankly, it's not a concern for me. I don't care.
Yeah, I mean, on the Windows side, you're not going to be running Linux Docker images on a Windows machine. I mean, that's not really going to happen, but yeah, Windows has announced that they're going to support Docker containers, so they'll have some kind of containerization model, which will take a few years to. So maybe in Windows 2020, Docker containers on Windows.
As successful as Silverlight was.
Yeah.
Nah.
Yeah. Good answer. All right, so Rocket, yay, now we've got another container solution. Do we care? Do we need it? Would you ever look at it? Is it on your radar at all? Do you know what it is?
I had asked Cora West Press to send me some Rocket t-shirts for today, but they haven't showed yet. Seriously, it's, they're all based on LFC. I think competition is good. I like having an actual specification. I think Rocket is sorely missing an API, which is one of the main things that the Docker daemon does.
Yeah, I actually think it's a good thing as well. It's going to be cross-feeding each other in each project. It's great to have competition. And it doesn't negate any of the benefits that Docker gives you. It's not like, oh, well, there's this other thing. Oh, well, it's no longer cool. I got to jump somewhere else. Like, well, then it wasn't really solving a proper problem for you to begin with. Who cares? Like, what came up first, RPMs or Debian packages? RPMs, wasn't it? I don't know. But then apps came along, and then there's this other thing. You'd still not use package management systems. Like, it still solves the problem that you need. So great. I think it's fantastic.
Yeah, the way I understand Rocket, which might be completely wrong, is basically that a lot of people want to run containers. They don't want to run it through a daemon that's running on root on the machine. They just want to say, I've got this process, I'm a user on a Linux machine, I just want to run this process in a container. And so Rocket kind of takes it back to the basics of just like run process in container. Don't go for an API, it's running as root, and then spawn a container format. It's more closer to the process, which, yeah, is good. Competition is always good. And yeah, it's a slightly different model, and they've started out with a spec. And obviously they got the benefit of hindsight of all the things that Docker did wrong, which is fundamentally flawed, and the whole argument that Docker is now a platform, which is in some way true. It's building up a lot of stuff inside the Docker ecosystem. And
the website says the Docker platform.
Okay, so Docker is officially a platform. So yeah, the Rocket isn't going to be a platform. It's just like bare bones containers that you can run locally instead of through.
I feel really bad for the original LXC nautical devs who worked on it and never get any mention now. SystemD and Swan, same thing. So this technology has been around for quite a long time. It's great that it's being standardized, and I think Solomon sometime last year gave a talk where he said that the main thing that comes out of Docker is getting people to agree on something. The technology is a side benefit. So from that perspective, it's a great thing, even if they have slight disagreements in the short term.
Cool. Hang on a minute. So, all right. So, actually, Phil, that leads us to the next question. Then, so you know, Rocket has maybe learned from some of the things that Docker got wrong. So, what are some of those things? What are some of the limitations, especially for you two who are close to production with your Docker things? What are you running into that you're like, oh man, this really sucks. I can't do some of the things that I want to in Docker, or did they actually get it all right? Is Docker essentially perfect?
Yeah, I mean, the only thing I can comment on is that going through the daemon, I think you should be able to just run it directly. Not have like privileges or part of a group. But I mean, that's the other thing I'm written.
There's also that all of this probably not going to work anymore, but you could just create a Docker container using the LXC runtime, and then just start it yourself through LXC once you created it. So you wouldn't need the daemon after that point. And it probably goes vice versa.
Yeah, that's really
if you're willing to dig out of the code, you probably hack your way around anything, but I don't care about having the daemon there. I've got other daemons that I probably trust less, and OpenSSL is everywhere.
I mean, the Docker format itself, it's a tarball with some JSON metadata, and you're really just kind of gluing them together in a union file system and saying, hey, here you go, jail it this way. Like, there's no, if it's an open specification, which I think they recently did because of pressure from Rocket, and I'm sure you could write your own runtime and maybe not do it through the daemon.
And another thing to keep in mind here is that the kernel technology that all these things use, so C groups, capabilities, and namespaces. There's a file system API exposed by the Linux kernel for this, so you can like touch files and echo and cat stuff into files and control it that way. And the original LXC scripts, some of them were just bash scripts, like LXC info and a couple of the others. So a lot of the things that Docker is actually using under the hood, or Rocket would be as well. There's other ways to get to it, other ways to control it. It's just the fancier, slightly better documented tooling on top that Docker and other things bring to the table.
Yeah, when we switched to Docker, we kind of took Docker, but then some things it didn't do. So once Docker created a container, we like tweaked it a little bit with some of those base commands. But our project is based on an open source project called Cloud Foundry, and at the moment they're rewriting a new layer of that, which is kind of analogous to like Kubernetes or Mesos, which is called Diego, and that uses a different containerization implementation called Warden. And what they've actually done is you can actually push a Docker image directly into Diego, and it will actually run that Docker image as a Warden container. It's got nothing to do with Docker, except that it uses the library from Docker to actually manage the layers. And then it picks out a few of the things like the ports and whatnot. But generally, things you care about is the files, and then the ports you've got to open, and a few other things. And then you can run it in any container implementation you want. And so it should be easy to transfer from one to the other. I mean, the worst case scenario, you could just export it from a Docker image as a target zip and then import it into anything else.
Mark, you were doing that on stage 22. So people complain about the Docker registry being slow and hanging on images. So various people had tarball workarounds.
Yeah, I was creating a base image and doing an apt update, and then I was touching every file in the container, and then because that new layer on top is pretty much the same size as the underlying one, I just squashed it, exported, imported it, and just squashed it back down to one thing because I just didn't want it kind of squashed. But yeah, I don't know. My
if you get updated like 190 times or something, or 146, I don't know.
Yeah,
you reach the limit of AUFS. And it doesn't work anymore.
Currently, where I'm struggling with is just integration with Docker and Mesos. It had its own executor or way of Linux groups, and it created Docker as its own. It had integration with Docker, and it's a first-class citizen, and so running a lot of that. Scheduling with Mesos, so having these two things coordinated with each other, there's a lot of rough edges there, and so the more that it becomes a platform, I think the more that because Docker is great as a building block. Once it becomes more of a platform, it is going to be tougher to integrate it to other platform as a service or to other future tooling, and that's where I'm a bit concerned about. And that's kind of where it seems to be sort of getting a bit contentious.
Good question. And we're going to spare battery when the mic just died.
Oh, died?
Maybe it was nothing.
Oh, you might have okay.
Yeah.
The big production issue for me is the networking. So I actually, I've forgotten who it is, from OpenDNS mentioned, Raheem mentioned Pipework at a previous Docker user group, which is essentially a bash script that abuses IP utils, network namespace tools to create a raw network device and attach it to your container. And unfortunately, that sort of reaching around under the hood behind Docker is still necessary if you're doing anything more than exposing a couple of TCP ports for like a web app or something. So if you want to use IPv6, it wasn't supported on recently. If you're doing high volume traffic through a container, it's going through namespaces, multiple hops, getting tied up in the Linux cradle, that sort of thing, and it's definitely not a good fit for like non-HTTP, non-TCP SIP protocols. Currently, unless Trav Tops is about to correct me.
Net equals host. So you can control what network namespace your network devices are attached to. So you can always manually create one on the outside and tell it to attach to a different one. Or you just do net equals host when you do Docker run, and your container will start in the host network namespace. So there's no, it doesn't do any fancy IP tables, masquerade, or forwarding of any kind then. So your existing network tooling, go at it. But yeah, the built-in way that it does it is both a little bit hard to understand and introspective first. And if you're really running a network where you care about throughput and latency, you might not always live up to your expectations. But I think it's good enough for most people. And Open vSwitch, you can work with it. No?
No comments.
Okay, so here's a scenario for you. Solomon gets hit by a bus, and you guys get appointed as Docker CTO. Where would you want to see Docker heading? Let's say it doesn't get hit by a bus. Where do you want to see it go? And what do you think is going to be the future of Docker?
I have no idea what the actual future is. I very much like the original vision of a portable wrapper around a single process that you could move wherever. So I continue to iterate and improve on that.
Yeah, I guess the concern that I was talking about before, I'd probably try to address that, which is be a bit more cautious about how you are going to monetize this platform that you created. this $40 million of funding. You've got to show some kind of return on that. You've got some real world pressures. It just seems a little kind of premature for certain kind of news on things. I think that all these new offerings of quantum machine and whatever, this kind of batteries included but removable, I don't like that. Just don't have a thing and then, hey, there's these cookies over here, don't bother them. So yeah, integration with making sure the integration with other platforms is the strength, because that's how you make most applications and most platforms sticky. Get everyone to use it, and so I think they're starting to edge into that. So I would, maybe kind of like step back a little bit. Don't be so scared about trying to have a return on your $40 million investment. So quite yet.
Yeah, in some ways, I kind of like the batteries included, but because a lot of people can get it in a single line and be running Docker images like straight away. As soon as you got to install all the batteries, it kind of kills Christmas Day when you realize you don't know any batteries.
Okay, we've tossed the batteries included phrase around a little bit. For those of us like me, say, who don't quite get exactly what you're talking about, can you clarify exactly what we mean by batteries included but replaceable with respect to Docker?
So things like what file system it uses, so like AUFS, or if you like different flavors of that, like PyUFS, or the networking that it uses, or networking, all those pieces. You can take those all away and implement something else. Even like libcontainer, which is fundamentally how the container is implemented, you can replace that with something else.
Right.
But so they're actually broken this all apart into different libraries that you can run your own library and replace it. Yeah, I was gonna say, what I think is, this whole daemon thing is just like getting bigger and bigger, and that makes me a little bit nervous because you've got this like thing running as root. It's got an API exposed and all these things can go through. Probably break that up into more pieces maybe.
Before I answer, the stuff you were talking about, how many of you have actually swapped the batteries out for other things? Whether you're running something that's not AUFS, playing with the networking, would you swap?
We're actually swapped it out for a different operating system. So.
Are you doing it?
Yes.
Yeah. We should get you up here. Honestly, if I was someone, I'd run away. I don't like big business problems like that. But and also, I turn off Twitter. So I think it's gone beyond just hyped technology to have it attracting haters as well. And some of the blog posts I've seen are just assholes just ranting about stuff some of them don't understand fully. So I'd run away, but I would hope that whoever would step up as a replacement would focus on running their business well, so they can support the technology. And don't get too distracted by open source competition in the way the form of Rocket and the underlying building blocks. Don't focus on them as business competitions, which they're not. Focus on providing value out to your customers. That's it.
Cool. All right. So that was a little airy fairy. Let's bring this right down back to reality. So as a segue to opening up for some more questions, we had folks submit questions on the meetup site. Some of them we've kind of covered already, but here's a couple good ones. So from Chris Giesel, do we have Chris here tonight? Awesome. So Chris wanted to know, I'd like to hear the panelists discuss the pros and cons of building containers from Docker files versus images, an ongoing debate here at work, wherever work is. Specifically having a container in a known state with specific software versions, etc. So from Docker files or images, how do you roll?
I do both at the minute. I think what's really important is having a manifest, so you know exactly what is installed. So whether it's your or app database or something else, it's very clear that building something repeatedly is a hard problem. Operating system packages won't solve it. Operating system mirrors won't solve it either. It's a very difficult problem. And Docker doesn't solve it either. And so you need to, if you care deeply about having exact matching versions, you're going to have to do a lot of extra work yourself. So it doesn't really matter too much whether you use a Docker file or an image. Use whichever is easiest for the thing you're building. It's my take home.
Yeah, I've got my Docker images being built with Ansible, so I'm not using a Docker file. And then sometimes I might use a Docker file, but really it just calls Ansible to go and like provision itself and bake in the metadata. A lot of our existing configuration management is kind of verbose and complex, and so I'm trying to encapsulate that into a Docker file so that we can choose what we want to do later as part of the build process. But we're layering a base image, which is common to everything. I install Ansible in there. I've tried many ways of trying to actually create a container with Ansible without installing Ansible. First with SSHD in there, which I don't like. Then there's trying to create some weird sort of thing of bind and mounting between containers and all sorts of other magic to try and get Ansible to do a local sort of kind of deployment inside the container. Anyways, create a base image. Sort of the application middleware or runtime stuff, and then from there build the application on top of that. So it's sort of, we've got kind of three layers, yeah. So kind of going, I'm kind of layering it manually, not sort of doing a doc file. It's like committing every single command. It's just more for our use case and transitioning from our existing legacy setup into this new kind of way, which allows us to then choose how we want to do it afterwards.
So, like building platform as a service, we have Docker under the hood, but you can actually bring your own Docker image or Docker file to it. We've obviously had this conversation a lot, like how would we implement it? So the pros of bringing a Docker image is, someone can build it, whether that's continuous integration or developer. And once that's built, you can pass that through the testing and the QA, and then add it to production and know that it hasn't changed, it's like set in stone. But then pushing a Docker file, the downside of that is usually, well, every time something touches it, if it has to build it, then you might get variability, like someone might have pushed something new to like Get repositories or Ruby gems, and then suddenly it's built slightly differently. The argument against that is generally, well, why do people push things to apt-get or Ruby gems? And generally, or maybe not Ruby gems, but apt-get also is generally security fixes. People fix security fixes, so if you're building it, there's a time lag. You probably want the latest security fixes in your image, rather than the ones you baked in a week ago that the QA has been testing for the past week or longer.
I do pretty much what Mark just said with Ansible, but I do it with Salt. I'll have a Docker file that does nothing but call into Salt local. And I honestly don't like doing apt-get this, apt-get that in a big Docker file. I'd much rather use tools that I've used elsewhere that are purpose-built for that sort of stuff. And I think you made a really good point that if you run a Docker file a week apart, you're probably not going to get the same thing. And that's a great thing. So the other thing that I do, it's probably quite different from a lot of people, is I run a build process inside of a container, and then I export, like what Mark was talking about before, I export that as a tarball and re-import it so I get a flat image afterwards. So I'm not building up a layer of images from my base Docker file. I'm using that to create my base image and then doing stuff on top of that. Mainly because for my dev tool, I'm going to use Gentoo. And Gentoo's got this big honking portage subdirectory that you don't want baked into your image. So Docker's another way of making me feel not so bad about using Gentoo.
So if you've only got one Docker layer, you really need to use that AUFS. Could you swap out those batteries for something else?
Yeah, so I use FNumber.
Okay.
Cool. All right, so one more, and then we'll turn it over to the audience. Now, I have an opinion on this next question, but you're not here to hear my opinion. We'll hear from the panelists. The question is, it comes from Gavin. He says, I want to know if it's possible to start containers, some of which may have runtime dependencies on other containers to be up in a certain order. Does this fall under the term orchestration?
certainly falls under the term orchestration, at least as far as I'm concerned. I haven't found a particularly neat way to do it just with Docker itself. You have like linked containers, and it essentially seems to boil down to shell scripts that do like a wait, netcat, check is the port open and stuff. And that's why I think things like Kubernetes and Mesos and other orchestration layers built on Mesos are particularly interesting. There may be a newer, more elegant way to do it, but anything I've seen in practice, either internally or in Cloud or on GitHub, it sort of boils down to using linked containers and shell scripts.
Yeah, I think what House keeps bringing up is configuration management, can help with that in certain cases. Really, the only time where I've had a more complex setup, it's not really that complex, is setting up a private Docker registry. So I had the registry, Redis, and Nginx, and you had to have Redis up for it to be able for the registry to link to it, and then Nginx would then open and or do the HD auth to secure it. And I had them all those containers starting up with Upstart. And so with Upstart, I say, well, it depends on this being started, and then it depends on that being started. So I created the chain that way. And it was just because I didn't really have any, at that point, I'm setting up the registry. So I didn't have any infrastructure around there. And that was just a kind of quick and sort of easy way to set it up. So when it boots, it does boot in order, just like, regular, sort of inner processes.
So, I mean, there's not a lot of difference between having a bunch of processes that you've got to start in order and a bunch of Docker containers, because essentially the Docker containers wrap around it. So I don't think there's any extra overhead with using Docker. If you haven't figured out the processes, then Docker's not going to help or really hurt you there. But I think generally, if you've got many processes that you have to start in a particular order, what happens when you need to restart one of those processes in the chain? Everything's going to go pear-shaped. So I maybe...
I'm surprised it took us 3 speakers to get to that issue.
Yeah. So yeah, maybe address that issue first, like how you handle like things going up and down. Because generally, Docker containers should be viewed as ephemeral, in my opinion. And so they should be able to come up and down. Or if you're running some of the, like Kubernetes or something, maybe it pops up somewhere else. So then you have like service discovery to find out where it is, and then you reconnect to it.
Pretty much what they said. The fact that they are just processes that you could use your existing tooling, your existing init tools, or supervision tools, I think is something that people forget about when they talk about this, because links really are stupid if people focus too much on links, Docker links. So the issue there, if you're not aware of it, is that links depend on the IP address of the containers. If you bring one down and back up again, and you've got other containers linked to it, well, its IP address might have changed, and your links are dead at that point. So you need something beyond Docker links to do that. But there's plenty of old school options or new school things, like what you guys mentioned, and also fake ways of doing it. You can even use Format for say little shell scripts that'll just start stuff in the right order. There's plenty of options. Just don't use links.
All right, so that concludes the joining on from our panelists portion of the program tonight. And so now we kind of like to open it up, make it a little bit more interactive, and take questions from the audience. So hopefully all of our kind of stories of getting Docker in production and some experience has juiced up your creative neurons. And what questions do you guys have? I'm sure we haven't answered them all because there's a whole ton. So somebody, I'm sure we could, there we go. Thank you very much.
Hi, so I'm just wondering if anyone at all here has had experience with clustering of the instances, running CoreOS and high availability, that kind of stuff.
So I helped teach a Kubernetes workshop in December, and it reinforced me that it's very data technology. That never questions about why does this command line option not match up with what the documentation says. And I played around just doing simple stuff using config management tools to do that, but nothing in terms of like elastic scaling up or down. I think you probably got it with Mesos.
Yeah.
More experience with that.
Well, that was one of the reasons why I like scheduler of resources. It's not trying to do service discovery or even scheduling. It's like the kernel and then other schedulers plugged into it. Like I put our build system running Jenkins registers into Mesos and is able to dynamically spin up slaves. So that we can have a multi-Jenkins instance or multi-master setup. So each team in our company can have their own Jenkins instance. But the slaves that are being used get shared. So it's a shared compute resource. So if one job needs to spin up 20 slaves, it can do so, or grab the entire compute cluster. After X amount of idle time, 5 minutes, whatever, it will release those slaves back into the compute pool. Because most of the time, the way I figure, and this is what eBay has done as well, is that a lot of the sort of build infrastructure just sits there idle. So why not just share it? So that's kind of where I've gone with it, and I feel that production is in production. It recently, as of 020, it's Docker is a first-class citizen in Mesos, and I know that like the whole platform as a service is still really nascent, and I think it's a really cool problem to work on, but. Yeah, I'm just a little cautious, so I want to put this stuff into a build environment. I think that's where a lot of people's introduction into Docker is like, well, let's get involved in the build process, and then we'll throw it into production. And that's kind of where we're at with Docker, but also with the orchestration and scheduling part of it as well, which is a huge kind of open question. So seeing how that works, and then moving into production. Yeah, there's a lot of rough edges around there, but.
Yeah, I played with Kubernetes a while ago, and yeah, I ended up sending a bunch of pull requests because I couldn't get things working, and then I was on the IRC, and everyone's like, yeah, I'm having the same problems, and yeah, it took a lot of work because all the instructions and the blog posts were completely different to what Kubernetes was, because there was no extra processes, and it split things apart, and it was moving so quickly that all the instructions were out of date, and so yeah, it was a lot of pull requests and got things running, and after like days and days of messing with it, I didn't really actually end up doing much with it because I didn't have it myself. But yeah, I mean, we use the Cloud Foundry open source project to orchestrate containers across a large cluster, so that's the way we use it. It's not very Docker centric, but yeah, we do that.
Okay. I'll give someone a beer if they can answer this question. What does Kubernetes itself use for orchestration under the hood? Well, not other than templates. Oh yeah.
No Googling.
You mean like etcd?
etcd and salt. So
I didn't get the salt. Half of it.
you can have salt in here.
Does it still have a hard-coded limit on the number of servers you can run Kubernetes across?
I have no idea. It's probably changed since last week.
I think you can't grow a cluster.
Oh, yeah.
You're fixed to a certain cluster.
Yeah.
You can't just add a
Right,
machine
so
if you suddenly want to do a bit more work.
Yeah, so that was one of the things a lot of students in this course in December ran into. There were some of the examples that we were running on, we were trying to get them to run that if they started with n equals 6, we quickly realized that they needed n equals 8 and they couldn't resize.
Anything else? Yeah.
Can you spell Kubernetes?
Kubernetes.
Go for it.
So as far as containerizing the application, your system, does it make sense to containerize your database server as well? Like if you're running Postgres, like I know you have to mount the volume and everything like that in case the Docker container shuts down or something, so you don't lose your data. So you have to mount an external volume to it. But does it make sense at this point to run your Postgres database or Elasticsearch database in a container?
I like microtanks last time I heard. Yes, that one. Somewhere else.
What?
Isn't that a drop in life, man?
It certainly has some advantages for like packaging, so trying to make sure that everything is running the exact same version, rolling out new versions relatively quickly. So keeping the libraries and that sort of thing nicely bundled is good, because I've upstream repository changing or whatever, we've had slightly different versions of like MySQL or Cassandra or something in production, and that can lead to weird issues. So I do think it definitely has some merit, and it's something. There is a Vsauce feature request to support persistent bit volumes, which I'm watching very closely because I think it would be a nice, elegant solution for it. That way, you know, like a bit of volume backed on like I guess Ceph or something that is persistent and always proficient with the container where it's executing and update the database. But it's definitely not something that I would go for running in production yet.
Does it affect the performance at all?
So there was a funny blog post where someone dug into this. They were doing the volumes properly, like bind mounting from the host. And they actually discovered, for some really strange reason, probably just to do with measurement, they should run faster inside, but even though it should be identical.
Yeah. Because of volume and mount, it's bind mounting inside, right? So
yeah.
I mean, it's just great and sort of on your hey, it's over here, right? So
But the fact that it was fast, it was just a
total
fluke. But so how many people run a database inside of a VM of some kind? So Docker will be a hell of a lot. So assuming that your host is not also a VM, if you got this on real hardware, Docker containerizing at the Docker level rather than through a VM would be a hell of a lot faster in terms of
if you look at MySQL or Postgres or something like that, where it's you think of it as like a singular entity. I think it's a bit more contentious. But what about if you provide, say, like a few thousand node React cluster?
Yeah.
Like, does it make more sense to containerize the runtime? I think like when you start thinking about it like that, where the database is no longer this singular like precious little cow, it's the herd argument, right? I think then you start. I think there's more weight to the whole containerization.
You just reminded me of something interesting that Plenty of Fish was doing. They ran into rebalancing issues with their large boxes running Cassandra. And they realized that Cassandra's really bad at rebalancing big nodes, but if you chop it up into a whole, chop the physical node up into a whole bunch of small virtual Docker nodes, then you just take them out of the pool and rebalance that way. It solves the problem for them.
Related to that, it's you can get pretty monstrously beefy database servers nowadays, and unless you spend a lot of time tuning and tweaking your workload, it can be very hard to really fully utilize like a quarter of a terabyte RAM and 24 cores. So Docker may also be, or Docker early containerization might be a good way to approach the resource limits. Saying give 10 instances, 2 cores, and however many pieces of RAM each, without having to worry about tweaking buffer pool sizes and making sure that each database doesn't steal resources from the other databases on host. It's something that we'll be looking at this year, hopefully.
Can you assign cores to Docker containers yet?
Using LXC column flags, or?
I guess you could.
Yeah, you can definitely bind processes to cores. So yeah, you could probably do it on the Docker set, but I have no idea how to do it with Docker.
All right, I got a question. So if I've fully Dockerized my environment now and I've got Docker images running everywhere, what's the monitoring like around this situation? I mean, if I've got a nice environment where I've got mixed workloads and I'm fully utilizing my hardware and I've maybe got like a multitude of different kinds of services on any given instance, if I'm looking at top, I see Docker. Like what tools are there to make that world work great?
Not much else. Sensu, which is developed by Sean Porter locally, looks very interesting for improving monitoring. I don't know the magic solution to it. Some people at SoundCloud are also working on something called Prometheus, which I think was all over Hacker News this week, which again looks interesting, but it's a hard problem, and I think cluster schedulers and supervision and restarting things and the sort of the airline and process supervision briefs are quite important here, so that if you have these ephemeral instances, they get restarted and no one gets paged because it just one machine died and it starts somewhere else and no one knows, no one cares. But I think monitoring is hard. I don't think there's an easy way to monitor it, and it's just using Docker. Sorry for
Yeah, I think that various locations you have on the machine, and then in the application, the stats can be heavily as you have sort of information coming from within the app. And is that process there or not? How's the memory usage, the usage of the machine? As an aggregate on the hardware, so you have this other abstraction layer now that I don't know. Yeah.
Okay.
I think, yeah.
So it's an open question.
It's an open question for me.
Yeah.
Well, in the Docker 4.5, there's the stats API now, which streams like memory usage, CPUs, and all those things that you could pump into some other system. And then on a higher level, there's the API Docker events, so that will tell you if a container started, stops, all those high level things. But yeah, I'm not really a monitoring expert, so that's stats.
So the Docker stat stuff, you could have actually done that back pre-Docker 1.0 also just by using old school stats tools that will set the list of PIDs. So top, for example, you have a Docker top, which runs, say, if you're using HTOP, you just pass a concept like a list of PIDs. So you can do PS to get your IDs, filter by the C group that they're running inside of, or you can just actually, in the product file system, you can go in and for each one of your C groups and each one of your Docker containers to be listed as a directory in there, get the process IDs running inside of it, and use a little bit of bash to pass that into HTOP. So that sort of stuff is there. But from a different perspective, if you think about running a big physical node and you've got a whole bunch of VMs running inside, you've then got 1 plus n schedulers. You've got the host scheduler, and each one of those VMs is now got a competing scheduler that is going to be putting load in the system in a way that may not be optimal in competition with the host scheduler or the other VM schedulers there. So if you're trying to look at monitoring from a perf, why I think slow perspective, I think Docker improves the situation there because you've actually got a simplified runtime. You've only got one OS scheduler running. And people were talking about trying to debug perf issues inside of VMs, bitch about the scheduler getting in the way. I have no idea why things happen at the times they do. And all the process stats you would get on a normal host level operating system process, they're available for Docker as well. There's various ways of, for a process running inside of Docker, getting just its stats. And these are based on tools that have been around for a very long time. Because they're just processes, you use those tools.
There's something you said with ephemerality, that the more ephemeral that our process becomes, then you have to start putting in other things to support it, like service discovery.
Yeah.
And with service discovery, you generally have some kind of health checking with that, otherwise it gets plugged in. So, for instance, console has that baked right in, we're using things in that, it will check in every morning and say, okay, hey, port 80, just do curl call every 10 seconds, is it up? Okay, great. And if not, you kind of don't care if it's running or not, just kill it and then move on. So I think it kind of maybe changes a little of like the responsibility for what monitoring means as well.
Yeah, cool. Okay, cool.
Right, there's one other downside, speaking of monitoring and logging. So in terms of kernel namespaces, syslog is one of the things that's not namespaced yet. So the logs from the containers are going to end up in the same dev log or kernel message space for the host. So you've got to be careful about that.
Cool. Any other burning questions, or should we break for networking and beer? Anybody else got something that they want to? So yeah, please.
So let's say I have a complex application stack, and I've Dockerized every single part of it, and they all have some dependencies, and I use something like Fleet or Kubernetes to orchestrate that. And let's say now I go on my development machine, make a change, whatever the thing is, right? And I make like a breaking API change or whatever, such that the set of dependencies will not work if I just deploy a single part of my stack. So how do you handle essentially deployments in that large scale?
Yeah, I think I think this relates more to like microservices architecture. So in that sense, you want to version your APIs. You maybe use immutable infrastructure. So that way you could have multiple versions of your API running. So immutable infrastructure is kind of like where you create version 1, and you put that out there in some Docker containers, and then you create version 2, and you push that out there, and it's up and running, but version 1 you never take down. So all the things that depend on it run on version 1. And then the dependent microservices, you can push those out and say, now you use version 2, so you push those out. But if they have any problem talking to version 2, they then fall back to version 1. So it's kind of a combination of like immutable services that you still have that old instance running if the new version doesn't work, and then baking into the dependent services that they should be able to fall back. And then a large part of that is service discovery, so finding out where all these things are running and the different versions of them.
So are there any tools that are available that kind of take or do that mostly?
Netflix uses this model, and they have open sourced a lot of stuff. So they use like Hystrix is one of the things they've open source, and that's for a lot of the service discovery. Eureka is another one for the service discovery, and then yeah, it's kind of failover and seeing if things are running and handling that.
I just had a question for the audience. How many people work with or have used Erlang other than Ken? I'm curious if any of you thought about using Erlang supervision trees in combination with Docker or something like it, containerization processes. No? Ken? Because it's a partial answer to some of that sort of stuff, like and the orchestration question, bringing things up, monitoring them as units, and making sure that you've got orderly restarts and all that sort of stuff. Many ways to skin it down.
Fair enough. Riza, did you want to wrap us up a little bit?
Sure.
Cool.
All right, let's get a round of applause for the panelists. That was awesome. Well, I hope you guys enjoyed today's session and learned a thing or two. I certainly did. Panelists are going to stick around for more questions. I don't know if you guys have, or you guys are shy about asking questions. So next month we're going to have another event for Docker's second birthday. There's going to be Docker and Go mentors on site teaching people about Go and Docker. So stay tuned. I'll be announcing that in Meetup soon. And that's pretty much it. Thanks OpenDNS for sponsoring events. And it's the end of the day. So enjoy the beers and everyone at home. Thanks, guys.
Scheduler of resources. It's not trying to do service discovery or even scheduling. It's like the kernel, and then other schedulers plug into it. Like I put our build system running Jenkins registers into Mesos and is able to dynamically spin up slaves. So that we can have a multi-Jenkins instance or multi-master setup. So each team in our company can have their own Jenkins instance. But the slaves that are being used get shared. So it's a shared compute resource. So if one job needs to spin up 20 slaves, it can do so, or grab the entire compute cluster. After X amount of idle time, 5 minutes, whatever, it will release those slaves back into the compute pool. Because most of the time, the way I figure, and this is what eBay has done as well, is that a lot of the sort of build infrastructure just sits there idle. So why not just share it? So that's kind of where I've gone with it, and I feel that production is in production. It recently, as of 0.20, it's Docker is a first-class citizen in Mesos, and I know that like the whole platform as a service is still really nascent, and I think it's a really cool problem to work on, but yeah, I'm just a little cautious, so I want to put this stuff into a build environment. I think that's where a lot of people's introduction into Docker is like, well, let's get involved in the build process, and then we'll throw it into production. And that's kind of where we're at with Docker, but also with the orchestration and scheduling part of it as well, which is a huge kind of open question. So seeing how that works, and then moving into production. Yeah, there's a lot of rough edges around there, but.
Yeah, I played with Kubernetes a while ago, and yeah, I ended up sending a bunch of pull requests because I couldn't get things working, and then I was on the IRC, and everyone's like, yeah, I'm having the same problems, and yeah, it took a lot of work because all the instructions and the blog posts were completely different to what Kubernetes was, because there was no extra processes, and it split things apart, and it was moving so quickly that all the instructions were out of date, and so yeah, it was a lot of pull requests and got things running, and after like days and days of messing with it, I didn't really actually end up doing much with it because I didn't have it myself. But yeah, I mean, we use the Cloud Foundry open source project to orchestrate containers across a large cluster, so that's the way we use it. It's not very Docker centric, but yeah, we do that.
Okay. I'll give someone a beer if they can answer this question. What does Kubernetes itself use for orchestration under the hood? Well, not other than templates. Oh yeah.
No Googling.
You mean like etcd?
etcd and salt. So
I didn't get the salt. Half of it.
you can have salt in there.
Does it still have a hard-coded limit on the number of servers you can run Kubernetes across?
I have no idea. It's probably changed since last week.
I think you can't grow a cluster.
Oh, yeah.
You're fixed to a certain cluster.
Yeah.
You can't just add a
Right,
machine
so
if you suddenly want to do a bit more work.
Yeah, so that was one of the things a lot of students in this course in December ran into. There were some of the examples that we were running on, we were trying to get them to run that if they started with n equals 6, we quickly realized that they needed n equals 8 and they couldn't resize.
Anything else? Yeah.
Can you spell Kubernetes?
Kubernetes.
Go for it.
So as far as containerizing the application, your system, does it make sense to containerize your database server as well? Like if you're running Postgres, like I know you have to mount the volume and everything like that in case the Docker container shuts down or something, so you don't lose your data, so you have to mount an external volume to it. But does it make sense at this point to run your Postgres database or Elasticsearch database in a container?
I like microtanks last time I heard you ask that one. Somewhere else.
What? You know, drop the mic, man?
It certainly has some advantages for like packaging, so trying to make sure that everything is running the exact same version, early versions relatively quickly. So keeping the binaries and libraries and the cluster thing nicely bundled is good, because I've definitely run into issues where because of like upstream repository changing or whatever, we've had slightly different versions of like MySQL or Cassandra or something in production, and that can lead to weird issues. So I do think it definitely has some merit, and it's something, there is a Vsauce feature request to support persistent type volumes, which I'm watching very closely because I think it would be a nice, elegant solution for it. That way, you know, like a bit of volume backed on like a Ceph or something that is persistent and always provisioned with the container where it's executing, and update the database. But it's definitely not something that I would feel comfortable running in production yet.
Does it affect the performance at all?
So there was a funny blog post where someone dug into this. They were doing the volumes properly, like bind mounting from the host. And they actually discovered, for some really strange reason, probably just to do with measurement, they should run faster inside, but even though it should be identical.
Yeah. Because of volume and amount, it's bind mounted inside, right? So
yeah.
I mean, it's just creating it sort of hey, it's over here, right? So
The fact that it was fast, it was just
total fluke. But so how many people run a database inside of a VM of some kind? So Docker will be a hell of a lot. So assuming that your host is not also a VM, if you got this on real hardware, Docker, containerizing at the Docker level rather than through a VM would be a hell of a lot faster in terms of IOPS.
Yeah, if you look at MySQL or Postgres or something like that, where it's, you think of it as like a singular entity, I think it's a bit more contentious. But what about if you go out and say like a few thousand node React cluster?
Yeah.
Like, does it make more sense to containerize the runtime? I think like when you start thinking about it like that, where the database is no longer this singular like precious little cow, it's the herd argument, right? I think then you start. I think there's more weight to the whole containerization.
You just reminded me of something interesting that Plenty of Fish was doing. They ran into rebalancing issues with their large boxes running Cassandra. And they realized that Cassandra's really bad at rebalancing big nodes, but if you chop it up into a whole, chop the physical node up into a whole bunch of small virtual Docker nodes, then you just take them out of the pool and rebalance that way. It solves the problem for them.
Related to that, it's you can get pretty monstrously beefy database servers nowadays, and unless you spend a lot of time tuning and tweaking your workload, it can be very hard to really fully utilize like a quarter of a terabyte of RAM and 24 cores. So Docker may also be, or Docker early containerization might be a good way to approach the resource limits. Saying give 10 instances, 2 cores, and however many gigs of RAM each, without having to worry about tweaking buffer pool sizes and making sure that each database doesn't steal resources from the other databases almost. It's something that we'll be looking at this year, hopefully.
Can you assign cores to Docker containers yet?
Using LXC column flags, or
I guess you could.
Yeah, you can definitely bind processes to cores. So yeah, you could probably do it on the Docker side, but I have no idea how to do it with Docker CPs.
All right, I got a question. So if I've fully Dockerized my environment now and I've got Docker images running everywhere, what's the monitoring like around this situation? I mean, if I've got a nice environment where I've got mixed workloads and I'm fully utilizing my hardware and I've maybe got like a multitude of different kinds of services on any given instance, if I'm looking at top, I see Docker. Like what tools are there to make that world work great?
Not just. Sensu, which is developed by Sean Porter locally, looks very interesting for improving monitoring. I don't know the magic solution to it. Some people at SoundCloud are also working on something called Prometheus, which I think was all over Hacker News this week, which again looks interesting. But it's a hard problem, and I think cluster schedulers and supervision and restarting things and the sort of the airline process supervision trees are quite important here, so that if you have these ephemeral instances, they get restarted and no one gets paged because it just one machine died and it starts somewhere else and no one knows, no one cares. But I think monitoring is hard. I don't think there's an easy way to monitor it, and it's just using Docker. Sorry for
Yeah, I think that you have monitoring in various locations on the machine and then in the application. It's asking heavily as you have sort of information coming from within the app, and is that process there or not? Is the memory usage, CPU usage of the machine, as an aggregate on the hardware? So you have this other abstraction layer now that I don't know. Yeah.
Okay.
I think
So it's an open question.
It's an open question for me.
Yeah.
Well, in the Docker 4.5, there's the stats API now, which streams like memory usage, CPUs, all those things that you could pump into some other system. And then on a higher level, there's the API Docker event, so that will tell you if a container started, stops, all those high level things. But yeah, I'm not really a monitoring expert, so that's stats.
So the Docker stat stuff, you could have actually done that back pre-Docker 1.0 also just by using old school stats tools that will set the list of PIDs. So top, for example, you can have a Docker top, which runs, say if you're using HTOP, you just pass a concept list of PIDs. So you can do PS to get your IDs, filter by the secret that they're running inside of, or you can just actually, in the proc file system, you can go in and for each one of your secrets and each one of your Docker containers can be listed as a directory in there, get the process IDs running inside of it, and use a little bit of bash to patch that indentation off. So that sort of stuff is there. But from a different perspective, if you think about running a big physical node and you've got a whole bunch of VMs running inside, you've then got 1+N schedulers. You've got the host scheduler, and each one of those VMs has now got a competing scheduler that is going to be putting a load in the system in a way that may not be optimal in competition with the host scheduler or the other VM schedulers there. So if you're trying to look at monitoring from a perf, why I think slow perspective, I think Docker improves the situation there because you've actually got a simplified runtime. You've only got one OS scheduler running. And people were talking about trying to debug perf issues inside VMs, bitch about the scheduler getting away. I have no idea why things happen at the times they do. And all the process stats you would get on a normal host level operating system process, they're available for Docker as well. There's various ways of, for a process running inside of Docker, getting just its stats. And these are based on tools that have been around for a very long time. Because they're just processes, you use those tools.
There's something you said with ephemerality, that the more ephemeral that our process becomes, then you have to start putting in other things to support it, like service discovery.
Yeah.
And with service discovery, you generally have some kind of health checking with that, otherwise it gets plugged in. So, for instance, console has that baked right in, these things and that, it will check in and point and say, okay, hey, port 80, just do curl call every 10 seconds. Is it up? Okay, great. And if not, you kind of don't care if it's running or not. Just kill it and then move on. So I think it kind of maybe changes a little of like the responsibility of what monitoring means as well.
Yeah, cool. Okay, cool.
There's one other downside, speaking of monitoring and logging. So in terms of kernel namespaces, syslog is one of the things that's not namespaced yet. So the logs from the containers are going to end up in the same dev log or kernel message space for the host. So you've got to be careful about that.
Cool. Any other burning questions, or should we break for networking and beer? Anybody else got something that they want to? So yeah, please.
So let's say I have a complex application stack, and I've Dockerized every single part of it, and they all have some dependencies, and I use something like Fleet or Kubernetes to orchestrate that. And let's say now I go on my development machine, make a change, whatever the thing is, right? And I make like a breaking API change or whatever, such that the set of dependencies will not work if I just deploy a single part of my stack. So how do you handle essentially deployments in that large scale?
Yeah, I think this relates more to like microservices architecture. So in that sense, you want to version your APIs. You maybe use immutable infrastructure. So that way you could have multiple versions of your API running. So immutable infrastructure is kind of like where you create version 1, and you put that out there in some Docker containers, and then you create version 2, and you push that out there, and it's up and running, but version 1 you never take down. And so all of the things that depend on it run on version 1. And then the dependent microservices, you can push those out and say, now you use version 2, so you push those out. But if they have any problem talking to version 2, they then fall back to version 1. So it's kind of a combination of like immutable services that you still have that old instance running if the new version doesn't work. And then baking into the dependent services that they should be able to fall back. And then a large part of that is service discovery, so finding out where all these things are running and the different versions of them.
So are there any tools that are available that kind of take or do that mostly?
Netflix uses this model, and they have open sourced a lot of stuff, so they use Historics is one of the things that like the source, and that's for a lot of the service discovery. Eureka is another one. It's for the service discovery, and then yeah, it's kind of failover and seeing if things are running and handling that.
I just had a question for the audience. How many people work with or have used Erlang other than Ken? I'm curious if any of you thought about using Erlang supervision trees in combination with Docker or something like it in containerization processes. No? Ken? Because it's a partial answer to some of that sort of stuff, like bringing, and the orchestration question, bringing things up, monitoring them as units, and making sure that you've got orderly restarts and all that sort of stuff. Many ways to skin it.
Fair enough. Riza, did you want to wrap us up a little bit?
Sure. Cool. All right, let's get a round of applause for the panelists. That was awesome. Well, I hope you guys enjoyed today's session and learned a thing or two. I certainly did. Panelists are going to stick around for more questions. I don't know if you guys have it or you guys are shy about asking questions. So next month we're going to have another event for Docker's second birthday. There's going to be Docker and Go mentors on site teaching people about Go and Docker. So stay tuned. I'll be announcing that in the meetup soon. And that's pretty much it. Thanks OpenDNS for sponsoring events. And it's the end of the day. So enjoy the beers and everyone at home. Thanks, guys.